Look up. You have done it thousands of times, without once stopping to confront the physical absurdity hovering directly above you. Since childhood, you have been taught that gravity is the relentless and absolute force of this planet, pulling every single mass toward the center of the earth without exception or mercy. Drop a stone and it falls. Jump and you return to the ground immediately. Everything obeys this unbreakable law. So answer me this one question. Why is the sky not crashing down on our heads at this exact moment? Most people look at a cloud and see something light and gentle, a soft cotton formation drifting peacefully across a blue background. I see something completely different. I see water, and water is extraordinarily heavy. A single average storm cloud, the kind you watch building on any ordinary afternoon, weighs more than 1 million kilograms. 1 million kilograms of liquid water and ice crystals suspended thousands of meters above your head. If you placed 1 million kilograms of steel in the air, it would fall like a meteor and obliterate everything beneath it. And yet that immense floating ocean sits up there, apparently mocking the same gravity that shapes black holes and governs the orbits of planets. I have spent my entire career trying to understand what in the universe is actually holding 1 million kilograms of water in the sky. And I can promise you right now that the explanation you received in school is a simplified and dangerously incomplete version of a physical reality that is far more violent, microscopic, and astonishing than anything your teachers described. Forget your intuition for the next few minutes, because human intuition is a clumsy instrument. It evolved to prevent us from falling off cliffs and to dodge moving rocks, not to comprehend the deep mechanical architecture of the atmosphere. To truly understand why 1 million kilograms of water is not crushing you at this precise moment, you first need to completely dismantle the childish mental image you carry of what a cloud actually is. A cloud is not a solid object. It is not a floating cotton blimp immune to physical law. It is a swarm. Picture trillions upon trillions of microscopic spheres of liquid water and ice crystals, each one separated from its neighbors by vast relative distances of air. And here is the first absolute truth that shatters your visual intuition entirely. The cloud is falling. It is always falling. At this very moment, every single water particle you can see in the sky is being pulled toward the center of the earth by gravity. Gravity does not switch off magically at 2,000 meters of altitude. Its force is constant, blind, and completely without mercy. So if the cloud is perpetually falling, why does it never violently strike the ground? Because microscopic physics operates according to geometric rules that your brain has never been trained to process. Everything comes down to the contest between mass and surface area. The air surrounding you, that space which appears empty between your eyes and the horizon, is actually a dense fluid. It is a chaotic, pressurized, thick soup of nitrogen and oxygen molecules. When any object falls through the atmosphere, it must violently push those molecules aside. That collision generates resistance. And that resistance pushes back in the direction opposite to the fall, which is upward. Think about a single raindrop striking your window. It is heavy and falls quickly because its concentrated mass easily defeats air friction. Now take that same raindrop and divide it into 1 million equal fragments until each piece is thinner than a single human hair. This is precisely what nature does when constructing a cloud. The total water mass remains identical. The total gravitational pull remains the same. But by dividing it to a microscopic scale, you have multiplied the exposed outer surface by a colossal factor, creating an enormous quantity of liquid skin for the surrounding air to push against. In fluid physics, surface area is everything. These new microdroplets have so little mass pulling them downward and so much surface area slowing them that air resistance almost instantly equals the gravitational force. When the downward force is mathematically identical to the upward force, acceleration stops completely. Physicists call this a state of perfect mechanical balance terminal velocity. And the terminal velocity of a cloud particle is laughably slow, just a few millimeters per second. If you watch a cloud carefully, you never see something static. You see a chaotic edge constantly sinking, dissolving, and reforming in real time. The entire cloud sinks through the air, the way a steel feather might sink through an enormously dense jar of honey. The descent is so agonizingly gradual that from the surface of the earth it appears to our limited senses as a completely motionless object. But pure logic immediately presents an unavoidable problem. If these particles are falling, even at a mere few millimeters per second, basic mathematics tells us that eventually, after hours or days, that 1 million kilograms must inevitably reach the ground. We would be perpetually suffocating in thick, permanent fog. And yet we look out the window and see clouds maintaining their majestic positions in the sky like enormous castles of ice and water. Terminal velocity alone cannot explain what we observe. A slow fall is not levitation. Delaying the inevitable is not defying gravity. Our mental model is severely incomplete. And to fill the gap, we need to introduce an additional force into the system, an invisible thermodynamic violence that most human beings pass through every single day without once realizing it is the only engine actually holding the sky in place. If you stepped outside on a sunny afternoon and felt calm and balanced in your surroundings, you would be completely mistaken about your situation. You are walking along the floor of a gaseous ocean that is boiling chaotically and ceaselessly around you. The greatest intellectual blindness of our species is the automatic assumption that what we cannot see has no force. The air enveloping us is not an empty canvas or a static backdrop. It is a thermodynamic engine of staggering brutality. To solve the mystery of why clouds do not collapse onto our heads, we must look downward, literally toward the asphalt, the soil, and the ocean beneath our feet, because everything begins with a colossal nuclear reactor positioned 150 million kilometers away from us. Solar radiation travels through the vacuum of space, passes through our atmosphere with minimal interaction, and finally strikes the surface of the Earth. Here is where the critical energy transfer occurs. The terrestrial crust absorbs that radiation and heats intensely. Through direct physical contact, the scorching ground then begins to bake the thin layer of air resting directly upon it. At this point, one of the most inviolable mechanical principles in the universe takes effect. When you inject heat into a gas, you are injecting fury into its molecules. Nitrogen and oxygen particles begin vibrating and colliding with massive kinetic energy, pushing violently apart from one another. The gas expands. As it expands, it occupies far greater volume while retaining the same quantity of matter. Its density therefore plummets. You now have enormous invisible bubbles of warm air sitting against the ground, surrounded and compressed by cooler, denser air pressing from above. What does physics dictate must happen next? The principle of buoyancy is not a suggestion. It is a law. The denser fluid sinks, forcing the less dense fluid upward. These immense thermal bubbles detach from the surface and are launched toward the upper atmosphere, not drifting gently but ascending as enormous pressurized columns, sometimes traveling at velocities of 5, 10, or 15 meters per second. Now connect this directly to the problem of our falling million kilograms of water. Those microscopic cloud spheres were sinking due to gravity at a terminal velocity of just a few millimeters per second. Visualize the mathematical collision occurring in the upper atmosphere. You have water droplets attempting to fall at millimeters per second, being struck from below by vertical columns of warm air rising at meters per second. The logic is simultaneously crushing and beautiful. Imagine trying to walk down an escalator moving upward. You descend at 1 meter per second while the mechanical steps push you upward at 3 meters per second. Your downward effort is completely futile. From the perspective of any outside observer, you are rising inexorably. The cloud is exactly that. It is a legion of trillions of passengers attempting to descend an escalator that ascends with overwhelming force, the thermal currents completely neutralizing the slow terminal descent of the microdroplets, suspending that million kilograms of mass through the sheer brute force of upward moving air. However, as a theoretical physicist, I must warn you that we have just walked into a fascinating logical trap. We have constructed a model where immense thermal currents push water perpetually upward, continuously defeating gravity. But if this elevator never stops, clouds should keep rising without limit, crossing the stratosphere and vanishing into the cold vacuum of space. Something is imposing an invisible ceiling on this planetary elevator, and identifying that ceiling separates genuine thinkers from people who simply memorize explanations. If you have ever observed a massive electrical storm from a distance, you notice something deeply unnatural about its shape. The upper portion of the cloud is not rounded or smooth. It is completely flat, as though it collided violently with an impenetrable glass ceiling somewhere in the sky. To understand that ceiling, we must follow our enormous bubble of warm air as it ascends and observe how nature charges it an unavoidable physical tax for every meter it climbs. Consider atmospheric pressure not as an abstract concept, but as the literal physical weight of all the air above your head pressing down on you. At sea level, you bear the weight of the entire atmosphere. But as our thermal bubble rises to 1,000, 2,000, or 5,000 meters of altitude, it leaves progressively more air below it. Consequently, far less mass is compressing it from above. The external pressure collapses. What does any gas do when the compression force surrounding it is removed? It expands. It swells like a balloon. But in this brutal universe, nothing comes free. For that bubble to grow, it must push the cold surrounding air aside to create space. Physics dictates that exerting that force requires energy, Since the air bubble possesses no external power source, it must pay using the only currency available, its own internal energy, its heat. As the gas expands to displace surrounding air, it consumes its kinetic energy and its temperature drops sharply. This is an unbreakable principle called adiabatic cooling. As our atmospheric elevator ascends, it cools inexorably. Eventually, the bubble chills to a temperature precisely matching the frigid surrounding air. When temperatures equalize, densities equalize, buoyancy vanishes completely, and the elevator stops dead. But this only explains why the ascent ends, not why clouds flatten against a ceiling with such violence. For that explanation, we must look slightly higher, to approximately 12,000 meters of altitude, where the rules of the game change in a grotesque and decisive way. That is where the stratosphere begins. The stratosphere contains something you know well, the ozone layer. Ozone absorbs intense ultraviolet radiation from the sun and heats dramatically as it does so. This creates a thermal inversion. While in our lower atmosphere air becomes progressively colder as altitude increases, the stratosphere does the precise opposite, becoming warmer with increasing height. When our cold, ascending cloud collides with that warm ozone layer, it is like striking a wall of solid steel. The cold, dense air of the cloud has absolutely no capacity to penetrate or float above that shield of warm, light air. It strikes the boundary and is forced to spread laterally in every direction, creating the massive flat anvil shape visible in every electrical storm. An invisible thermodynamic wall has stopped 1 million kilograms of water. The mechanical mystery of suspension and arrest is solved. But I must confess that I have been lying to you by deliberate omission. I left an enormous gap in our logic intentionally to see whether you would catch it. I have been describing microscopic liquid water droplets floating at 10 or 12,000 meters of altitude. Stop and reason through this carefully. Up there, the ambient temperature is minus 20, minus 30, even minus 40 degrees Celsius. At minus 40, water is not a liquid. It is solid, dense ice. It should freeze instantly, solidify into massive hail, and fall from the sky like a shower of rocks, completely destroying our elegant microdroplet theory. Yet, you look upward and the cloud is liquid. How is it physically possible for water to defy its own freezing point? Prepare yourself, because the answer is going to shatter your understanding of water permanently. Your entire life you have accepted one simple rule without question. At 0 degrees Celsius, liquid water becomes ice. School confirmed it. Your refrigerator confirms it daily. You accepted it as an unchangeable universal truth. That rule is a half-truth. It is a massive simplification designed for minds unwilling to engage with the astonishing and complex architecture of matter. If you enter the upper region of a storm cloud where temperatures reach minus 20, minus 30, even minus 40 degrees, you will be soaked by liquid water, not pierced by solid ice. How is this physically possible? To understand this apparent violation of basic chemistry, you must stop thinking about temperature as a simple on-off switch and begin thinking about geometry. You must think like a microscopic architect. Liquid water is absolute chaos. Its molecules slide and collide with one another in constant random motion, possessing no organizational structure whatsoever. Ice, by contrast, is pure order, a rigid and perfect hexagonal crystalline lattice. The genuine physical problem that no one explains to you is that transitioning from the chaos of liquid to the precision of ice crystal requires instructions. Water needs a template, a starting point. Physicists call this a nucleation site. In ordinary daily life, tap water contains microscopic impurities everywhere. Dust particles, dissolved minerals, bacteria. When you place that water in a freezer and the temperature drops to 0 degrees, water molecules use those impurities as foundations. They attach to a dust particle and begin constructing their hexagonal crystalline architecture immediately. But at 10,000 meters of altitude, the microdroplets composing our cloud are extraordinarily pure, consisting almost exclusively of isolated water molecules. When the temperature falls to minus 10 or minus 20 degrees, the molecules lose energy, slow dramatically, and desperately want to freeze. But they cannot. There is no foundation available, no dust, no minerals. You have millions of microscopic workers ready to construct an ice palace, but no one has delivered the architectural blueprints. So the water remains liquid in a ghostly, unstable state, perpetually on the edge of collapse that physicists call supercooled water. It is water desperately waiting to freeze, requiring only a single trigger to transform instantaneously and violently. When a microscopic particle of cosmic dust or a wind-carried atmospheric spore collides with one of these ultra-pure droplets, the reaction is immediate and brutal. In a fraction of a millisecond, the entire liquid droplet solidifies into a rock-hard ice crystal. This is among the fastest transformations observable in nature. and it represents a lethal danger to aviation. When a commercial aircraft wing passes through one of these supercooled clouds, it provides millions of nucleation sites simultaneously. Tons of ice crystallize violently across the wings within seconds, distorting aerodynamic profiles and threatening the entire machine with catastrophic loss of control. Our central mystery, however, remains unresolved. We have constructed an immense atmospheric machine. The sun heated the ground, air ascended, water rose, cooled dramatically, and now exists as these unstable supercooled droplets. Eventually, some droplets encounter those particles and successfully freeze. Now you have a microscopic ice crystal, 1,000 times smaller than a grain of salt, floating kilometers above the Earth alongside supercooled liquid water. Yet when you observe an actual storm through your window, what strikes the glass is not invisible microscopic ice. It is large, heavy liquid drops. How does a crystal invisible to the naked eye grow massive enough up there in suspended air to break free of terminal velocity and defeat the brutal upward thermal currents? The physics governing that growth process is one of the most merciless mechanisms in atmospheric science. It involves direct molecular theft. Nature is not a peaceful place. You were taught to see rain as a gentle and harmonious gift that waters fields and fills rivers. What I see is a microscopic battlefield governed entirely by the law of the strongest. Inside the frozen upper regions of the cloud, two neighbors share the same space under compulsion. Supercooled liquid droplets, desperately wanting to freeze, share the atmosphere with the fortunate few that already collided with dust particles and became solid ice crystals. If you imagine them floating together in peaceful coexistence until they decide to fall, you have fundamentally misunderstood thermodynamic brutality. The ice crystal is not a peaceful neighbor. It is an absolute parasite. To understand the mechanics of this systematic theft, you must stop viewing the air inside the cloud as empty space. That air is saturated with invisible water vapor molecules. Both the liquid droplets and the ice crystals are engaged in constant silent competition to absorb that surrounding vapor. But in this contest at sub-zero temperatures, the ice crystal holds an overwhelming and deeply unfair physical advantage. The secret resides in the strength of molecular bonds. The water molecules forming the rigid hexagonal structure of ice are bound together with vastly greater force than the chaotic, loosely connected molecules of liquid water. Ice captures and retains vapor molecules with extraordinary ease. Liquid water requires enormous effort to do the same thing. What does this mean in the physical reality of the cloud? At 30 degrees below zero, liquid water is too molecularly weak to retain its own substance. The droplet begins evaporating slowly, bleeding its own water molecules into the surrounding air. The ice crystal positioned millimeters away acts as a relentless thermodynamic magnet, absorbing that escaped vapor instantly and incorporating it directly into its own solid structure. Physical contact between the two is never required. Through the air itself, the ice crystal is literally draining the liquid droplet to death. Physicists call this molecular cannibalism the Bergeron process. Over the course of minutes, millions of liquid droplets shrink, evaporate, and vanish entirely. Their total mass transfers completely to the ice crystals, which begin expanding at a terrifying rate. The tiny invisible fragment of ice transforms rapidly into a massive geometric structure, an enormous snowflake. Now the rules of the entire system change dramatically. The crystal's mass is now so absolutely substantial that gravity can finally claim its inevitable victory. The crushing weight of this new frozen giant completely overwhelms the thermal current that previously held it suspended. The thermodynamic elevator breaks. The massive snowflake begins plummeting, tearing through the wall of ascending warm air that once supported it effortlessly. As it accelerates downward into progressively lower atmospheric layers, it encounters warmer, denser air. That rising temperature attacks its perfect crystalline structure, destroying the molecular bonds holding the lattice together. The frozen giant melts in milliseconds and transforms into the large, heavy, violent liquid drop that finally strikes your window. That is the complete journey. That is the true and mechanical anatomy of a storm. There is no magic. There are no cotton clouds. It is an implacable mechanized cycle of evaporation, freezing, parasitic molecular theft, and finally inevitable gravitational collapse. But precisely when you believe you have mastered this system completely, physics delivers a direct blow to your confidence and dismantles your new certainty. This entire violent model depends absolutely on one condition: the existence of ice and the molecular theft process operating at temperatures well below freezing. So answer this. Travel to the jungles of the equatorial regions, to the hottest zones on the planet, and you will witness massive and violent storms forming constantly. But in those burning locations, the lower clouds maintain temperatures well above freezing throughout their entire depth. No ice crystals, no Bergeron process, no microscopic parasites stealing vapor molecules. And yet water falls from the sky with unmatched destructive fury. If ice does not exist to grow the droplets, how does 1 million kilograms of tropical rain form in the heat? In the tropics, the enormous ground heat launches vapor and air into the atmosphere with unrivaled intensity. But temperatures never drop below freezing before the ascending air mass becomes completely saturated with vapor. Above you sits a massive, heavy, violent cloud composed of pure liquid from top to bottom, containing zero ice. Our elegant theory of sub-zero thermodynamic theft collapses entirely. But gravity forgives nothing, and that immense volume of water must fall. This is where pure and brutal physical collision between liquids takes over completely. The key to this new mechanism lies in the inherent imperfection of nature. When invisible water vapor condenses around atmospheric dust particles to form microdroplets, the process does not produce identical sizes. Some central dust particles are slightly larger, such as the fine salt crystals carried from tropical oceans by prevailing winds. Others are microscopic. This creates an enormous population of water droplets born with minutely different diameters. In the unforgiving world of aerodynamics and fluid physics, that tiny geometric difference determines everything between permanent suspension and gravitational death.